Hi, we're from the University of Alabama presenting our final project for our Physics 126 class, Electricity and Magnetism.
This is our 4-bit maze we've built. It consists of 4 LED lights, 6 push buttons, 4 220 ohm resistors, 6 2.2 kilo ohm resistors, and a bunch of wires. However, the resistors, we didn't have enough of those particular values, so we had to use ones that were very close. They're not exact, but it still works, as you can see. Now, how this works is you start with, as originally showed, 4 lights all on. And the goal is to get to a state where all 4 lights are off, which seems simple enough. However, the code, which was provided by Todd Mueller, we're not entirely even sure how particular it follows, or it goes. But it's randomly generated. Each maze is randomly generated. So each particular path for that maze is consistent for that maze, but the path we follow is random to us. So really, you could be on a path to where you think you're getting closer, but you never really do, because there's no indication that you are, since it's all random. You could be going down what you think is correct, but you'll just eventually end up in a loop that that won't solve it itself. So you'd have to backtrack to try to get to a different path that will lead you down the correct way, so you can finally get it off, or done. As this may show, just at this point already, going between yellow and green leads you just to the opposite state. So you're going to need a good memory to memorize that, okay, doing this particular, starting with this red, going to this state, and just going from green to yellow only goes back and forth to each other. So that's one you can already eliminate. However, as you go, you get to this state, try red, and it goes different. So you just have to keep going until you can find the correct path. But this, of course, may not have already been just because we pressed this button first. And if you have an Arduino, which will run a serial monitor, which will show you, in our case, the states that can be active for this maze. We have been using this just to see that this actually works correctly. And we'll be able to show you that for this particular maze, number 10,059, these are the states we can have. The numbers on the left being which state it is, which are always 16 for each maze. The numbers in parentheses being how many steps from that state till you get it correct to state 0, which is off. You always start at state 15. And it may be difficult to see, but state 15 for this maze has 8 steps. So if you were to follow the correct path from the beginning, it would only take you 8 button presses to get to state 0. And we're going to use this particular maze to demonstrate, since it's shorter and easier. And as a note, the way this shows each button state is run from left to right. However, the way the code is run and how it's wired, the buttons actually run from right to left. So where here shows 8, 1, 2, 3 for the first state, that's actually 8, 1, 2, 3 from right to left. So that's also a note to remember, that if you're using the comm monitor, you'll have to remember to adjust for that. And we've already done the correct path for this maze just to demonstrate. So you want to do that?
Yeah.
Ta-da. Simple as that. But of course, that's with us using the comm monitor to actually track what's the correct path. Of course, if you don't have that available for you, you're just going to see 4 lights on and just have to go at it on your own, which could take a while. Since